Fairish? Fairish? Good, good. What's the easy shortcut? Give myself a graph?
Zoom 9.
Zoom 9. Zoom 9, thank you, Corey. Boom, boom. Okay, I love this. I'm going to finagle a smidge, if it's okay with you guys. Just a smidge, just a smidge. I'm gonna drop, Sarah, I think it was Sarah or Jessica, one of you guys, Beth, you guys asked me about how to get the box plot down. Was that you guys? Great question. Almost always, when you press Zoom 9 and you have these two graphs on, they're almost always going to lay on top of each other like that. Because when TI developed this, they weren't thinking, I'm assuming, of us graphing more than one thing at a time. One of the easiest ways to pull the histogram away is just go to your window and change the scale to like a more logical number. So since I had you guess by 5s, just change it to 5. Change it to 5. And then if you want, you can also mess with the X-mins and the X-maxes. I'm going to change the X-max to 195. And the reason for that, your highest guess was 190. And the way these things are set up, they're 5 wide. So if the lowest guess is 150, the first bar is going to go 150 to 155. It's only going to count the 150 guesses, but it's going to count that in that bar that's 5 wide. The next bar is going to go 155 to 160, but it's only going to be counting the 155s. So in order to see 190, I've actually got to go 190 to 195. It was going to 196, so we were okay, but now and this is the German and talking with the Italian. So fair enough? Sorry. Hit graph. There we go. That did the trick nicely. That did the trick nicely. Ish. Yeah. So I like the graph. I like the graph. How would you describe this, friends? How would you describe that? I hear vote for bell-shaped. Who seconds? Who seconds bell-shaped? Bell-shaped. Go ahead. Second, third, fourth. Be brave. There's no right answer. Do you think it's bell enough? Do you think it's bell? Let's decide right now. Let's do a quick decision. We're going to use Pearson's. Remember Pearson's? I remember that you hated it. So we have an average of 170 pounds. My friends, would you tell me the median? It's also 170. Now, not that we don't need it to do Pearson's, but I'm going to try to guesstimate. Don't tell me what the standard deviation is. I'm going to try to guess it off the graph. Okay? Let's see how I can do this. I got within 0.2 pounds last class. No pressure. 10 pounds. Oh! Oh! 9.6. Thank you. Magic? Hell no. What did I just do? What did I just do? It looked like I was chopping, Dave. Very good point. It looked like I was chopping, but I wasn't chopping. What did I do? We did this in. It's been a while since we did this in class. Corey. I basically went and I tracked the middle 95% of the data. Now, middle 95% of the data, if the data is bell-shaped, should contain
2 standard deviations.
It is 2 standard deviations. Come back to that. Hold that thought for 45 seconds, Tabitha. What percentage of the data should be within 2 standard deviations? 95%. So, since I can't eyeball 2/3, it's too noisy for 2/3 for me. I can't do a 1/6 and a 1/6, but I can do 95%. And then I said, okay, that's 150, that's 190. What's the distance there between those two? 40. And it's 2 standard deviations, right? So
divided by 2.
S, 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 that's 4 S's. 40 divided by 4 is 10. So it's not magic. But if it's bell-shaped, you can get a real quick estimation of what the standard deviation is. And here's why I think it's bell-shaped enough. You guys, Cassie, you said it's about 9.4 pounds, right?
No, 9.6.
9.6. What the hell? We'll call it 10. But here's the deal. It doesn't even matter. It doesn't even matter because I wanted to see if it was skewed at all. Pearson's coefficient, you take the average and take away the median and divide by that.
But if the denominator is 0, it's going to be 0.
But if the numerator is 0, the skew is 0, and a skew of 0 means what? That the data is basically bell-shaped. When there's no skew, go ahead, Corey.
Less than 0.2.
Nice, man, nice. Pearson, or it wasn't Pearson, Hildebrand, I think, said any absolute value of the Pearsons less than 0.2 is considered bell-shaped enough. So it's 0. That's definitely less than 0.2. And 0 means perfectly bell-shaped. And this is not perfectly bell-shaped because the average is not exactly 170. It's a little bit off of 170. But it's essentially 0, which means it's essentially perfectly bell-shaped. So that's why I felt pretty good slapping my hands up there and going, okay, 95% divided by 4, we're done. Is that fair? You guys buy that?
Yeah.
Awesome, awesome. Now, that 95% actually brings us to our first order of how to measure outliers. Where I put my hands at 95% actually tells us the limits of what typical looks like in a bell curve. So let's come over here. And remember, this is a humanly invented construct. This is a humanly invented construct. This isn't like a law somewhere written down in a physics textbook like gravity is 9.8 meters per second squared. This isn't like if you measure a skid mark on a road after an accident, you can reverse engineer how fast the cars were going. Those are all based on physics, based on laws, based on friction, based on gravity, observable. This is something that human beings created to try to quantify unusual events in statistics. So here's number one, first way to find outliers. And I prefaced it with that somewhat loud, obnoxious introduction because there probably are dozens of these ways. And I don't want to do dozens of these ways in this class, if it's okay with you guys.
Well, can't you just take the total amount and then just subtract it from the 95% and then that will give you the outlier?
That's exactly, but what I want to do is I want to put this down in writing because this is the first time we've talked about it, Raphael. Yes, essentially what we do, and there's a big if that goes into this. If you have bell-ish shaped data. And Corey, thank you for that point 2, Hildebrand point 2. That was very nice, my friend. Don't memorize it. But I'm so stoked that you had that. Remember, you had that in the back of your pocket. Your job is to make the call. Does that look bell-shaped? Well, it's off now the way it is right now. But when you graph that, did you guys get that gut feeling? Yeah, it's bell-shaped enough. It's got some tails, and then it rises up in the middle. It's not perfect. It's not. Did you notice there's a little hump at the one end? Did you guys catch that? Yeah? There's a little hump at the end. And there's more variability out on this side. Dave, going back to Dave's measure, there's more variability here than here. Probably because the data spread out more than it is over here. It's not perfect. In a perfect bell curve, it'll be perfect. That box plot is basically perfectly symmetric. But the question is not that it's perfectly bell, it's that it's bell-ish. It's bell-ish enough. So you're not looking, what you're not seeing is, you're not seeing this hump over here. You're not seeing that, like you saw in your exam grades. Or, thank God, you're not seeing like you didn't see on your exam grades. You're not seeing this crazy, you're not seeing bimodal distribution. You're not seeing that. What you're seeing is fairly centered, yes, just like you said. The lion's share is in the middle and then it tails off. Just beautifully said. So, if you have bellish shaped data, I'm going to rewrite what Raphael said about 5 minutes ago. The typical data points are going to be within 2 standard deviations of the average. That's how we define the typical. Now, the reason I'm defining that, I just got that a little caveat before saying that outliers aren't always the big ones or the little ones. Sometimes they're in the middle, not in bell-shaped data. In bell-shaped data, the normal ones, I shouldn't say that, the typical ones are in the middle. So that's where your typical data points are, within 2 standard deviations. So here's what I want to do. Real quick, I want to do, as an example, for the weight guesses. For the weight guesses. For the weight guesses. Okay. 2 standard deviations, as you remember from your last exam, that's the average plus or minus 2 standard deviations. 2 of the actual S value of the standard deviation. Now you guys told me the average was 170 plus or minus, I think it was 9.4, I believe, is the number you guys used for this. I'm going to go back and use that, or 9.6. 9.6. I'm going to go back and use that, just to kind of get more of the I know I had you round off to the nearest 5 pounds. So in this case, that would be 170 pounds plus or minus 2 times 9.6 pounds. So if we do that math, that's going to be what? 19.2, this guy right here. So 170 minus 19.2 should be, is that 150.8? Check my math on this, friends, it sucks. 150.8 pounds, that's down 19.2. And if I go up 19.2, it's going to be 189.2 pounds. At least one person check this to make sure I'm not full of crap. I got 1 thumbs up. We got 2, 3, okay, I'm feeling better. 4. Chance of us all being wrong is exponentially decreasing, that's good. More on that in your next project. The idea of redundancy. One of the most important, this is a sidetrack. I'm excited with where we're at. We're at week 5. Class is essentially half over, which I can't believe. I'm just starting to know all of your names. Corey's applauding. Very nice. But I'm excited because we're getting to that point where we're transitioning out of just statistics into statistics and probability. We knocked on the door today when Jess asked me, wait a minute, you said there's about 8% of you should have all different years. The other 92% should have at least 1 year repeated. Why is that? That's the next part of the course, understanding why randomness clumps. Essentially, randomness clumps because it's too damn hard not to. We're going to figure out ways to quantify that. Like, I trained you guys now, when I say random, you say clump, you know, and it's like a football cheer. But now, we have to...
I was ready to do it.
Random.
I was too.
Random!
Clump!
Random! Random! I love this. Football cheers is second. I love it. But now, the question is how clumped, right? Quantifying. And that's where everyone loses interest, because they're like cheering, they're like measuring. But nonetheless, we're getting to that point. So we're getting to that point here too. How close is too close? Here's your typical guesses. Did we have any atypical guesses? So the atypical guesses are going to fall outside that range. Fall outside of 2 standard deviations. So did we have any atypical guesses?
2 at 150.
We did. We had 2 folks that guessed 150, and we had somebody that guessed 190. So the 2 150s are a little too low. Go ahead, Chris.
Never mind.
No, please.
No,
Are you sure? Well,
I was just going to ask if the 150 would be lower than that.
nice, very nice. And this again, remember, these outlier definitions are just that. We've created them, and they're not provable. They're not like gravity, where the sun rising in the east, the clouds raining when they're full of rain. If you call this 10 versus 9.6, this would go 150 to 190. Then you would get in this fist fight is, okay, were the 150s in or out?
Yeah.
Because these are parentheses, aren't they? Then you have to get this fist fight. I don't want to get a fist fight. I would say we got some, these ones on the end might be a little bit too extreme. The ones in the middle, as Cassie pointed out in the beginning, most of the data is in the middle. That's the typical. As you get further out in the tails, they're getting more and more typical. This is a somewhat artificial marker for where we've now gone too far. We've now gone too far and we're too small or too big. Okay? This is why when I ask these kinds of questions on assessments, there aren't often one correct answer. You guys might say something's an outlier where somebody else would say it's not, because you decided to set up the standard deviation around to a tenth or around to a whole number. And I'm not going to get in a fist fight about that, and you shouldn't either. But I think we all agree that the 150s and the 190s are pretty, I'm 170 plus or minus 3 pounds. So you want to know what my actual weight was? I'm right about 170 plus or minus 3 pounds. I mean, honestly, depending on what time of day and when I last ate, and how much water I've consumed, I'm either 173 down to like 168, somewhere in that neighborhood. So you guys are targeting my weight pretty damn well. You're actually targeting my weight. I mean, look, this is my weight. Most of you are getting within 5 pounds of it. Hell yeah, that's pretty damn good. That's pretty damn good. You guys are accurate estimators of my weight. Even in baggy clothes, as Tabitha pointed out. Just more intentional. Actually, I always kind of wear baggy clothes, so. Cool? Fair? And that's why I didn't want to tell you my height for a couple of reasons. Number one is that my height often yields a lower weight by correlation. Because when we figure out how tall I am, people often guess a little, well, never mind. We'll do that next. But this right here is a great, very common use of standard deviation to measure typicality or atypicality that gets used in the world today. But it only works if you have bell-shaped data. It will not work in general otherwise. So if you have highly skewed data, it won't work in that respect. So let's try to generate some skewed data. Let's just try to generate some skewed data right quick here. Turn this off. All right. I would get back up on the desk again, but I think that might actually skew your bias. Guess my height to the nearest inch. Should I stand up nice and straight? My hair down. Hang on.
Stand next to you?
Yeah, can I stand next to you?
Well,
Cheating.
well, I don't shit. You can stand up. Stand up, because if I put you next to me, then it almost has like then we're measuring versus kind of guesstimating. And I'm trying to test your guesstimation. Put my hair down. Hang on. Keep the hair lower.
I'm going 7'8".
7'8", plus or minus a foot and a half. We get on the desk, but I think that might make it worse. Plus, would be 12'2". Go nearest inch. Feet in inches. We'll convert it to inches to make the math easier, Francesca. Francesca, not Francesca. Francesca.
You know you told us your height like the first time.
No, I didn't.
Yeah,
Did I?
yeah,
Son of a
you
bitch, I did.
Yeah.
Wait, who remembers it?
Oh, yeah, I can imagine.
We'll take you guys. If you do remember it, we'll take you out of the mix.
But you were on this around and you told us the exact.
Son of a.
Nope.
On the first day,
This bit is
I
not
know,
gonna
I
work.
remember those.
No.
I did it in the last class on a completely unrelated note. They asked. We were talking about Max and his second year checkup, and they asked me, "Is there any other measures? Are there any other measures that nurses sometimes use to approximate how big a kid should be?" I was like, "Well, I can't think of any off the top of my head besides the body surface area, body mass index, the typicals. But there is one that's used called a mid-parental height to figure out how big a kid should be by the end of their full development of growth. And what you do is you average the mom and dad, their heights together, and add 2.5 inches. And then I actually ran the math with them using my parents as an example. So I guess I didn't do that with you guys. I gave my height away some other way. Son of a bitch. So we'll collect data for those of you that don't remember it. That's okay, and then we'll see how the people that don't remember my height or my height can target it. So let's do guess my height. We'll go over there. Go a little bit further up to the right. Sorry, I gotta put my samurai knot back up.
Flower in
It
your
is.
hair tie?
My friend Amy went to Hawaii, and I said, "What'd you give me?" And she brought home 4 of those for me. She's like, "I dare you to wear them." I'm like, "Hell yeah, I'm gonna wear it every day." The thing lasts a month and a half. I don't know if you guys use hair ties. A month and a half on a hair
That's a
tie.
long time.
That's an eternity.
That's really long.
I know. These things are ridiculous.
Well, look at your bun.
All right, so you can see G in here, folks.
Don't talk about her bun.
Yes,
You needed to mention that?
my height. All right, so let's hear some guesses, friends.
5'10".
5'10", that's 70 inches. Anybody go below 70?
Oh, I have covered.
Well, then just tell me your feet in inches. We can convert it. So 70 is 5'10". Anybody go 5'8"? 5'9"? You got a 5'9"? Anybody go below 5'9"? Okay, so 5'9" is a low ball. So this is height in inches. And then we got a frequency count. So we got 5'9", which is 69 inches. We got a 70, that's 5'10", 5'11", 5'12", or 6 feet, I guess. Anybody 6'1"? You got a 6'1", 6'1"s? 5'13", very nice. 5'14", aka 6'2", 6'3"s. Okay, so we got all of our, this is cool. We got them all within 5 inches. That's cool. How many 69, how many 5'9"s? 5'9"s, we got 1, 2, 3 5'9"s. 5'10"s, 70 inches, 5'10". 1, 2, 3, 4, okay. 5'11"s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7, I know. 6 foot even, 72 inches. 72, we got 2 6s, and 6 1s. We got a few 6 1s, huh? 1, 2, 3. All right. This thing looks pretty bell-shaped to me, doesn't it? I mean, already, before we even grab it, looks pretty bell-shaped. And those of you that remember my true height, it was 5'11", yeah, 5'11 and a half. 5'11 and a half. My modal height is when I've gotten it measured is 5'11 and a half. What's interesting though, I always get it measured usually late in the afternoon when I go for my checkups, and I'm riding my bike over to the checkup, and I'm thinking, I've heard that you're taller in the morning. You've been laying down in bed. Gravity's not pulling you down. You kind of spread out, and it's not like you gain 3 inches in like height, 2 feet to head. But when you stand up and gravity starts working on you, it starts just pulls your body down. And so I'm probably a little bit taller in the morning. So we'll go with 5'11 and a half. Let's see how you target it. Looks like you targeted it pretty well as far as the 5'11. Looks like maybe a little bit on the lower side because of the 3 and 4 versus the 2 and 3. nonetheless, let's get some data. Let's get some summary stats. What's the matter?
I wonder if you have tremendously like inverted. You ever use an inversion table?
What's an inversion table?
Oh, it's when you get
You have your
distracted.
creative and the table rotates, you make your equal.
Oh, I've heard that's wonderful though.
It's awesome.
It's really
Yeah.
good for your spine.
Yeah.
Like back
There's
problems.
actually I think it's Buddhist monks believe that if you could spend your entire life hanging upside down, you live forever because the force flows from your heart back to your brain. And apparently there's a belief. I mean, it would suck to hang upside down your entire life. I know, as Angie's pondering right now, like that would really suck. But you basically live forever because you'd have that life force, the chi, I guess, would be constantly recycled from your heart to your brain. And you'd be upside down all the time, which means you couldn't eat, drink, or pee, except in your own face. So that would kind of suck. So that would kind of, exactly. So, I don't know if I want to live forever. It'd be child abuse. So I would well, yeah, maybe.
Let's try it.
Let's try it. All right, so we got 69 inches, 70 inches, 71 inches, 72 inches, 73 inches.
3, 4,
10,
2, and 3.
2, and 3. Awesome, awesome. You could probably just go for a zoom stat right now with five separations. There's really no reason to finagle it all. Yep, there she is. Oh, look at that. That's kind of cool. That is kind of cool. I'm gonna adjust the Y up a smidge. Just get the box plot. What's up with that box plot, friends? How is that box plot different than every other box plot we've created today and last week? We've now created about 12.5 box plots together.
There's no
What
meat
is this? Yeah.
Well, it doesn't show.
Okay, so where is it?
Is it on one of the lines?
Exactly, Chris. It means that 25% of you, more than 25% of you guessed the same number, which obviously you can tell by the results. 10 out of roughly 20 guesses, just about half of the guesses were 10. Or excuse me, were 511. So when you try to break up the data set of 20 data points into 25%, it's just all the way back to what you said earlier, Athena. All the way back. Each of these increments, I know, usually it's less subtle. Or more so, I should say. Every one of these increments represents 25% of the data. But if any one data point occurs more than 25% of the time, that means you're going to have a median and a quartile equaling the exact same thing. Huh? So if you want, press trace, get up onto the box plot. The lowest guess, as it shows, is 69. The next highest is 70. It's marked as Q1. It's telling you, therefore, that roughly 25% of the responses were less than 70 inches. And if you look at that, you're like, okay, I can buy that. I can buy that. 3 out of 20. That's ish 25%. I mean, it's a small data set. So you have to have some leeway with percentages. So 3 out of 20 is about 15%. That's ish 25% on a small data set. But look when you jump up. When you jump to median goes to 71 across the way, and then Q3 is also at 71. See? So what they're saying basically is 71 being the median means half the data points guessed were below 71. Well, that's kind of an understatement because you have 10, which is the lion's share of the results right there, plus more. So you've got well more than half. So this, again, small data sets behave a little bit unpredictably sometimes with that. So those literal halves and 25% aren't literal half 25%. So, would you call this bell-shaped data? No? Okay. I have a vote for no now. This is good. My gut is yeah. Why not? It looks, but Tina, what are you looking at?
Well, I guess it could be.
No, tell me why you think it wasn't, because you're not wrong in saying it's not.
There's just too much data in the middle, even though it's supposed to be bell-shaped, and you have the extreme change on the end.
I love this. And unfortunately, we don't have the time to. I'll tell you what. Let's do this. Let's save this data for next class and come back to it. I don't want to rush through it just to get it done today. So let's do this. You guys, I'm going to show you a way to, because I'm going to send you home with some stuff to do between now and next time. And you're probably going to want to use your TIs, and I don't want to lose this data. So if you would, let me do something real quick here. If you would, go into your TIs. You got your data in L1 and L2. What I want you to do is put your data into L5 and L6 so you don't erase it. Because chances are if you go home and start using your TIs, you're going to erase L1 and L2 and replace it with other stuff. So here's the easy way to do that. Wander over to L5. Put your blinker on top of L5. Okay, with me so far? Then press second 1. Then press enter. And it'll put all the stuff in L1 and L5. And chances are you'll forget it's over there until Wednesday, which is totally fine, because then we'll pull it back up and use it. Do the same thing with L6, but do second 2, exactly. There's our data in L5 and L6. Here are the guesses from the other class, L3 and L4. Save all the data too. We'll come back and play with that. Because I want to go back to what Athena said, which was awesome, totally awesome. It's like the opposite of too spread, it's too tightly clustered. So, let's say that again.